So the last part of 5.2 is looking at a quadratic function that's in fact or in vertex form, and picking out the key pieces. We're not going to have you graph with this. We're just having you look at, you use the pieces that we find and you can use it to graph. But the main idea here is we want to make sure that you can look at a quadratic in vertex form and figure out which way it opens, what the vertex is, what your domain and range is, and um, and really, if you know one other point, like if you plug in 0 for x, then you can find your y-intercept and then you have enough information to graph. So when we look at this one, our direction of opening is still that value that's in front. So the a value tells you if it opens up or down. Remember, if it's positive, it goes up. If it's negative, it goes down. The vertex is the hk. So notice that it's always the opposite of the sign inside. Okay, so if it's minus h, then we do a positive number out, and then k is whatever it needs to be. So if it's plus h, then it's a negative h for your vertex. Domain is still negative infinity to infinity, and range is still based off of the k value of your vertex. All right, so if the parabola opens up, then your range is going to be from your k value of your vertex to infinity. If it opens down, then it's going to be from negative infinity to the k value of your vertex. So when we look at this first example that's in vertex form, the negative 3 tells us that it's going to go down because it's negative. The 4, 7, we take the value that's inside. So we're going to go 4, 7. That's your vertex value. And then our domain is always negative infinity to infinity. And because we know that it goes down, then we know that it's going to be from negative infinity up to that value of 7. Now, if I wanted to graph this, then I would need one more piece of information. And so I could find a y-intercept and say, well, to find a y-intercept, I would need to know what happens when x is 0. And then you could plug that in. So I could go negative 3, 0 minus 4 squared plus 7. And when you go to graph it, the problem with vertex form is a lot of times our numbers get really big really fast, because you'll notice that if I do negative 4 squared, then that's 16. 16 times negative 3 is negative 48 plus 7, which would give me negative 41. And so my y-intercept would be negative or 0, negative 41. That would be really hard to graph that and figure out what it's going to look like. And so, yes, I could do it, but if I was going to graph, I would need it to be a smaller number when I plug in 0. All right, so when we look at example 4, kind of the same idea. When I look at the direction of opening, I'm looking at the 5. The 5 tells me that it's going, because it's positive, it tells me that it's going to go up. The vertex is going to be the opposite of what's inside. So it says plus 8, so we're going to do negative 8. And then the value that's on the outside, so negative 3. Domain is always negative infinity to infinity. And then range is going to be, because it goes up, so think about what it looks like. It goes up, so it's going to be from this value of your vertex, which is negative 3, and then it's going to go up forever to infinity. And so we always want to make sure that we remember like which way is it facing, so that we can kind of understand what our range is going to look like, because it's always based off of that. All right, and so that's everything. Same idea. If I wanted to find a y-intercept to help me graph, I could. But again, it often will just give you a really large number. So 5, 0 plus 8 squared minus 3 is going to give us another y-intercept of something quite large. So this is going to be 5 times 64 and then minusing 3. And so can I do it? Yes. Is it always the best option? No. So this is 320 minus 3, so it looks like 318 or 317. I probably should make sure that's right. 5 times 4, 20, 32. Yeah. All right. And then subtract 3, 317. So that would mean your y-intercept is 0 and 317. When your numbers are that big, it doesn't really help you to graph. But it is an option if you were asked to graph it. Most of the time from vertex form, we're just really looking for the generals, like does it go up or down? What is my vertex? What's my domain? What's my range? But if I could find a y-intercept that works nice, then it might be easy for me to figure out another point so that I can graph. Because remember, you need to have um, a vertex and then something else in order to make a nice picture. So either a vertex and a y-intercept or a vertex and x-intercepts, but you need something more than just a vertex in order to graph your parabola. All right, so make sure you ask questions if you have any. Thank you.